So it converts a high-level language to a low-level language prior to runtime. Now, why do we need it? What's the purpose of these guys? So that's what it does. Go ahead.
Helps make applications run faster and smoother.
Okay, fair enough. Helps apps run faster and smoother. So I would say not a wrong answer. Maybe not necessarily the answer I was looking for, but I'd give you credit for that. Any other reason? Go ahead.
It makes it easier for us as programmers to make the program because low-level language is harder to code in.
Yep, so that's really the big deal is it allows humans to write software more easily by letting us use high-level languages rather than low-level languages. Make sense? The other answer, though, is not incorrect. If you remember from the slide, I kind of wanted you to focus that compiled languages are faster languages. So that's a true statement. So we do need them because they are faster languages. But from a human being perspective, we like the fact that compilers exist allows us to write software in high-level languages. All right, questions about that? Okay, so hopefully most of you got that right. I think we talked about that concept several times, right? Okay. All right, so last time we were in the middle of our Microsoft story, right? Okay, so we talked about platform independence of Java and how it pulls it off by porting the Java virtual machine, the JVM, over to multiple platforms, allowing the programmer to write their code once and run it anywhere that the Java virtual machine exists. Okay, so Sun Microsystems, now called Oracle, I say now called Oracle, they didn't change names. The company Oracle purchased Sun Microsystems and now they fall under the same company name, but Oracle existed beforehand. Anybody know what Oracle's famous for? What's their main product line? Larry Ellison, their CEO, is in that top 10 richest people thing. They make a database product, database management system. The product is called Oracle. So if you've ever heard of a product like MySQL or Microsoft SQL Server or PostgreSQL, IBM DB2, these are database management systems. Kind of the one that's considered to be the highest end, or certainly one of the high-end ones, is Oracle. It wouldn't be something that you or I would use for our own little applications. We would use probably a free database management system, but it's something like Amazon or eBay would use, where you're having to look up customer records and information about various items or whatever millions of times per second. It's made for that kind of thing. But that's what Oracle's famous for, is a database application. Okay, so platform independence. Microsoft tried to steal it. I think I gave the example of, dude, you missed a quiz already. Already. Do you know what a compiler is?
Converts low-level language to high-level language.
You would have missed it anyways. It's the other way around, high level to low level. Why do we need them? To who?
I don't remember what.
Killing me. I guess I'm glad you missed it, that I didn't have to. I wouldn't have had this banter had you not missed it. All right. So I think we used the example about a kid in underwear writes cool software, Microsoft steals it, pays them off outside of court. Kid accepts cash and they're happy about that. Sun Microsystems doesn't fall into the same boat, right? They're a major company with millions and millions and millions of dollars. Doesn't quite roll over and play dead like a lot of Microsoft's victims. One of Microsoft's business models, and I actually say this in somewhat of a positive sense. I guess in general, I'd say from a technology perspective, Microsoft is not the enemy. They are a large, very valuable, very rich company that has to make decisions within what makes sense for their business. So one of Microsoft's business models is if somebody has something that we want, sometimes the most effective way of us getting it is to steal it, then pay them outside of court. That's okay. A lot of people have benefited from Microsoft stealing their stuff and then them suing Microsoft financially. It's completely possible that those people would never have been able to take the product to the next level given their resources. Okay, so Microsoft leverages their expensive lawyers and their cash to do that type of stuff. Well, Sun Microsystems was not going to be a victim of this. So they fought Microsoft in court, won the court case. Microsoft had to give up their right. I think we had our thing here. At some point, I probably had J++ over here. So I had that last time, and then we deleted it. Okay, so Microsoft tried to create this. They got sued, had to get rid of it. Okay, so that's where we left off last class. But Microsoft still liked this idea of platform independence. That is, they liked the idea of write the program once, run it anywhere. So they decided to build a brand new, from the ground up, 100% Microsoft created language. That was their words. Microsoft was bragging about, oh, we got this brand new language we're making. It's going to be the best thing since sliced bread. Yeah, we lost this lawsuit with Sun Microsystems, but hey, it was actually a blessing in disguise. It gave us the opportunity to go and realize our own brand new programming language, which makes Java look like junk. Okay, and they called this language C#. I was at a ACM conference at the University of Illinois in Urbana-Champaign when they announced this. Did I tell you about this last time? Everybody, when you're at conferences like that, everybody always goes to the Microsoft talks, not because they like Microsoft, it's because Microsoft gives away the best free crap. Okay, other places are giving away little bouncy balls or keychains, stuff like that. Microsoft was giving away unopened boxes of Visual Studio Professional 6.0, which had a retail value on eBay of about $600. Okay, and most of us programmers had already pirated it, so we already had it. So what did we do? Well, we sold it on we sold it on eBay, made our $600. So then we figured we might as well stay for the talk. And so the guy's up there, and he was one of the lead designs or something like this on the C# thing, and he's talking about all these features that's going down the list, down the list, down the list, and he was basically describing Java. But remember, it's a brand new, from the ground up, 100% Microsoft created language. But he was describing Java. Okay. So they came out with C#. And C# was supposed to be platform independent, just like Java. It was based on the C++ programming language, just like Java. Now, the one thing to keep in mind, not to throw Microsoft too far into the bus related to this, is C#, they were describing Java, but remember last time we talked about the lineage of these languages. When Java came out, it had to look a lot like C++ because they wanted to bring over people who already had a competency in that language. You know, otherwise, if they made something completely alien, it might have been difficult to get adopters, people to actually start programming in the language. So when C# came out, the real question is, I mean, obviously Microsoft was going to copy Java as much as they could because they liked some of the things Java was doing. But realistically, they also had to base it off of C++ because they wanted to grab the same audience of developers. So I don't know that I would throw Microsoft too far into the bus for their language looking shockingly like Java, because Java looks shockingly like C++. Kind of make sense? All right, so it was based on C++. and looked a lot like Java, had most, if not all, of the features of Java. Okay? But most importantly, it was not Java. From a lawsuit perspective. From a lawsuit perspective, it was not Java. Had a different name, and they changed at least some of the words. Okay? And it did not run in the Java virtual machine. Fair enough. All right. So let's then, I'm going to steal one of these lines right here. So let's look at how C# pulled off the platform independence. So again, this is the Java model. You write your source code once, you run it through the Java compiler, it converts it into the low-level language that's called Java bytecode, which knows how to execute on the CPU written-in software called the Java virtual machine, which then runs through an interpreter during runtime and interprets this low-level language to this, interprets this low-level language to the low-level language that runs on this CPU. Make sense? So this is a one-to-one, this is a one-to-one, so it has to map between the software CPU and the hardware CPU in order to actually run. That's how Java pulls off platform independence. Well, let's look at how C# does this. And you could actually replace C# with .NET if you'd like to. C# is part of the .NET thing, but I'm going to call it C# here. So we have the C# source code. We run it through the .NET compiler. This produces something called missile code. That is Microsoft Intermediate Language. That's missile code. Microsoft Intermediate Language is a low-level language that has a one-to-one relationship with something. Okay? Now, again, it does not use the Java virtual machine. Instead, it uses the .NET component architecture. .NET CA. Which then uses a series of just-in-time compilers to ultimately produce native low-level code for the Intel CPU. Okay? Now, again, C# is advertised by Microsoft as being platform independent. Great, just like Java. So why use C#? Well, there's a catch. First of all, we don't have the performance hit with C# like we do on Java, because this is a compiler at this point rather than an interpreter. And what that means is the very first time you run the program, very first time you run your C# program, it goes through this just-in-time compiler. So it takes a little bit longer for it to run the very first time, for it to launch. Because what it does is it compiles the missile code, the Microsoft Intermediate Language, into native low-level code. And once it's done that once, now it's pre-compiled code for every additional time you ever run it. So it's natively running on the CPU. So it'll be fast. Okay, fair enough. Where every single time we run our Java program, it's being interpreted from this Java bytecode to native low-level language. So this is always being interpreted. This compiles the very first time you run it, and then it's native from that point forward. So .NET seems faster, right? So we can give Microsoft credit for this, saying, hey, they did actually improve from a speed perspective over Java's model. And again, Microsoft still claims it's platform independent. This little catch. So that means I should be able to take the same model, let's throw a let's do it here. So PC.NET component architecture, and we'll say Mac.NET component architecture. So now we can take our C# code, send it to the .NET compiler, which turns into Microsoft Intermediate Language. So the first 3 steps here are identical to the first 3 steps here. Then it's going to run through the Mac.NET component architecture if you're running this on a Mac, as opposed to the Java virtual machine, which works in conjunction with just-in-time compilers, which then runs natively on the Intel CPU. There's a problem. Really what Microsoft is saying is that C# is platform independent on, let's see, it's platform independent on any platform that supports the .NET component architecture. Now I'm going to rewrite that just a little bit. Translate it, if you will. C# is platform independent on any platform. As long as it's Windows. You can run it anywhere. Any platform you can think of, as long as it's Windows. Because they only wrote the .NET component architecture for Windows. So this guy right here is a pipe dream. Sure, it's platform independent. If Microsoft decided to write the .NET component architecture for Mac, C# code would run over there. If they decided to write the .NET component architecture for Linux, your C# code would run over there. But they didn't. So when they said it's platform independent, they were lying. They were saying it's platform independent as long as you're running Windows. As long as you're running our platform. It'll run on any of our platforms, no problem. That's really no different than C++. Now, having said that, why do you think Microsoft did not port the .NET component architecture over to Mac and over to Linux? Why didn't they write this multiple times like Sun did with Java? Go ahead.
Copyright suing reasons?
Copyright suing reasons? No. I mean, Microsoft could have certainly written software. I mean, they had already written Microsoft Office for Mac. So they could have written software. I mean, this is just a piece of software. So Microsoft's writing that software for their own operating system. They could have gone and written that for the Mac as well. Go ahead.
They created their own language. Why help their competitors?
Oh, okay, go a little deeper with that. Who is Microsoft's competitor?
Apple.
Okay, why is Apple Microsoft's competitor? In what way is Apple Microsoft's competitor? Just saying Apple isn't good enough yet.
Well, operating system.
Specifically from an operating system perspective. When we hear the phrase PC, we immediately think Windows, right? Microsoft is not a hardware company. Microsoft is a software company, hence the soft. Okay? Sure, they sell hardware, they sell keyboards and crap like that, but that's just from companies they bought that might make those things, right? You can't go out to Best Buy and buy a Microsoft computer. You buy a computer that's running Microsoft Windows, that comes preloaded with Microsoft Office, right? Microsoft is a company that makes operating systems. They make the Windows family of operating systems. And then secondarily, they make Microsoft Office. That's their other cash cow, right? And then their other cash cow is the Xbox. Kind of those three anymore. So Microsoft makes operating systems. When you say they don't want to help their competitor, why would they want to make it so that their competitor, that is Apple's operating systems division, could draw more people off of Windows and onto Apple's Mac OS? They don't want that. They don't care about Apple's hardware division because they're not in competition with that, right? In fact, by today's standards, now that Mac uses Intel processors, I mean, that helped Microsoft, didn't it? I mean, I tell technologists that if you're going to buy a new computer, the correct machine to get is a Mac. Not because Apple's better. You know, I mean, it's like a Cadillac versus a Chevy. They're both going to get you to work. You know, a computer is a computer. This has the same guts in it as your Toshiba. Same processor, same brand memory probably, same hard drive. There's no difference except this metal casing on the outside. There's one little catch though. On a Mac, you can run the Mac OS. You can also run Windows. I can install Microsoft's operating system on here and dual boot and run it natively on this machine. So I have two machines for the price of 1.7 because Macs are considered to be expensive, right? So fair enough analogy. It's 1.7 the cost, 1.7 times the cost of just a PC with the same specs. If you go and get a PC, she can't run the Mac OS on that. There's a product called Hackintosh, well, a project called Hackintosh that sort of, kind of, maybe, but not really lets you hack the Mac OS onto a PC, but it'll never run right. Okay, so really, if you, in part of your job, you need to be able to run Macintosh stuff as well, your only option today is to buy a Mac. So you can run Mac and Windows. Okay? Well, so Microsoft was thrilled. It's like, oh, well, we already had those freak shows running the Macs, right? They might as well buy Microsoft products too. So now they're buying Windows for their Mac. Microsoft just increased their install base. So it's an important thing when you see statistics about the percentage of install bases that Microsoft Windows has versus Mac OS or versus Linux, that's including Macs that are running Windows. Plenty. How many of you are have Macs in here? Either in class here or at home. Out of the people who have Macs, how many of you also have Windows installed in your Mac? Most of us. And the only reason you probably don't is your hard drive's too small. Because you have an Air. That's an Air, right? Yep. So you have an 11.6-inch MacBook Air. Great little laptop. But he probably has either a 128 gig solid state probably. The smaller one?
Yeah.
Oh, so you have a 64 gigabyte solid state drive. Now, you're not fitting a whole lot of operating systems on that. That's his limitation, and the trade-off is the portability, right? Okay, so in any case, why would Microsoft do this if all it does is allow more people to write software for other people's operating systems? Microsoft's already running their operating system on both machines. If you're a Mac user and you need to run a program that was written in C#, you install Windows by paying Microsoft money for Windows, and then you run that program. Microsoft still gets their money, right? Okay, so there really was no financial benefit for Microsoft to port the .NET component architecture over to the Mac or any other platform, which made it a little bit weaselly that they said it was platform independent, because it really never was. It was never platform independent. Now, having said that, there is a project called Mono. It's on Mac and Linux. So let's call this Mono. Call this. That's fine. Mac Mono. And we'll call this Linux Mono. And these projects have attempted to emulate the .NET component architecture on Mac and Mono so that people could write C# programs using the C# syntax and run it through the Mono's compiler so it would run natively on those machines. Still not platform independent. You couldn't then take that over to Windows and run it. But you probably could take your source code over to Windows and with minimal modifications have it running in Visual Studio using the .NET component architecture. The problem with this project, which has really matured, it's very good. You can go out and just do a search for Mono C# or something like that, and you'll read all this stuff on it. So it's a very mature project. It's been out for a long time. But the problem with this project is they're solving a very difficult problem. That is, Microsoft's .NET component architecture is not open source. So Microsoft knows about the magic that's inside that software, but doesn't share it with anybody. So Mono has to look at what's going in and has to look at what's coming out of it and try to mimic what's happening on the inside with their own ideas. That makes sense? And keep in mind, since Microsoft wrote the .NET component architecture for their own operating system, Microsoft Windows, they also have detailed knowledge about how their own operating system works, which is also closed source. So Microsoft could have written portions of the .NET component architecture in terms of secret abilities that Microsoft Windows might have built into it that nobody else knows about. So Mono is trying to copy functionality of the .NET component architecture without really knowing how they pull it off. They're just looking at what's going in and what's supposed to come out and trying to mimic it the best that they can. Okay, and some things just aren't compatible because of the way Microsoft can make it work with their operating system. They could pair these two together. In fact, even if you never write C# code, so I'm guessing most of you in here have never written any code in C#, but many of you in here, most of you in here run Microsoft Windows, right? You ever had an update on your machine that said it was updating .NET? Sure you have. Whether you read what the updates are or just said install the 13 important updates. Okay, Microsoft.NET updates on your machine automatically because large portions of the operating system rely on this component architecture. It doesn't just rely on it if you are a C# programmer. Okay, Microsoft Office runs in terms of the .NET component architecture. If you've ever downloaded a program off the web and you don't have the runtime .NET component architecture, sometimes it'll install that for you. It comes with it. So this doesn't mean you don't have this only if you're a C# programmer. Everybody in here who is running Windows has used the .NET component architecture whether you knew it or not. All right, so not really platform independent because Microsoft doesn't play nice with their competitors. They're in the business of making money off selling operating systems, not selling computers. Apple is a little bit different company. Apple sells hardware and software. So, whenever you have one of those people that come up to you and say, well, Apple's just better than insert other company, okay? Apple's solving a much easier problem. Apple is writing software for their own hardware. They know both sides of the coin. So they can control how this runs on their own stuff. When you think about Microsoft Windows, they're writing a piece of software for 1,000 different computers. All the HP computers, all the Dell computers, all the computers that people make out of their own parts at home. It's supposed to work on all of those. Okay, we could take that exact same model and take it into the mobile side. How many of you in here are iPhone users? How many of you are Android users? The rest of you, right? So let's call it half and half, iPhone and Android users. So the Android user would say, we like Android, we don't like iPhone. iPhone users would say, we like iPhone, we don't like Android. Generally speaking, right? Well, when you hear somebody bragging about iPhone, what do they say? Well, iPhone's better, it's got all this stuff. Android people are like, oh, it's too closed. They have these arguments. iPhone has the better end user experience. Fine. There's nothing impressive about that. It's because Apple controls the hardware and the software. No wonder everything just works seamlessly together. And things that wouldn't work seamlessly together, they don't allow you to do. Which is one of the benefits the Android users get from Android. One of their complaints is, well, I want to do X, Y, and Z, and Apple doesn't let me do that. Well, Apple's decided they don't want you to do that. So it's actually shocking how good Android is, considering that they're solving the old Microsoft problem. They're writing the single mobile operating system to run on all of these different phones, different screen sizes, different speed processors. Some of them have a rear camera, some of them have a front-facing camera, some of them have both, different resolution cameras, all these different parts. How many of you who are Android users have been long-time Android users? A couple of you? Haven't you seen how much that operating system's evolved over the last 5 or 6 years? 6 years ago, Android was crap. Okay? Today, Android's pretty polished. In fact, you can make the best argument today that Android's caught up to iOS in terms of end user experience. And really the best evidence of that was when Apple released iOS 7. which took some plays out of Android's book. iOS 7 for iPhone looked a lot like some of the Android stuff. Okay, so kudos to Google. They've done a pretty amazing job, but they're solving the old Microsoft problem, writing software for everybody else's hardware, as opposed to Apple, who writes software for their own stuff. Okay, kind of two different business models. All right, so that's C#. That's where C# fell into the equation. And back in our lineage here, C# fits kind of right here in a timeline. But really, if we wanted to just build a tree, you have C++, which had object-oriented weaknesses. That is, well, C++ had the object-oriented benefits, but had the weakness of allowing direct access to memory and empowered programmers to make bad choices. Java and C# fixed that. Okay, Java fixed it initially, and then C# fixed it, and then C# took the ideas that Java had, but then added a little bit to it. And you don't want to discount this from C#'s perspective, because this component right here is very, very important. The idea of just-in-time compilers. Because Java then went and took that and at least partially integrated it into their runtime, making Java programs run at least a little faster than they used to run. Okay, by putting in a just-in-time compiler that took Java bytecode and had it run natively on the CPU rather than go through an interpreter, at least some of it. Okay, so certainly Microsoft's idea here benefited Java from a technology perspective. Microsoft's idea here did not hurt Microsoft at all. Even though we can joke about it and say, okay, well, it's platform independent as long as you're running Windows, that doesn't really impact Microsoft because a huge swath of people are running Windows. It's not like he cut off half of the population, right? They gave up like 6% of the population. And out of that 6%, probably 50% of them are also running Windows. Okay. They didn't really hurt themselves very much. Okay, so C# did bring some innovation to the table that Apple did not. Or I'm sorry, that Sun Microsystems did not through Java. Okay, so then off of that, I have something I like to call the big three. That is Java, C#, and Objective-C. Okay, so going back to our little lineage chart over here, we had C at the top. Off of C, we have Macintosh, well, we have Apple and Microsoft not agreeing with each other. So Apple adopted this language called Objective-C. Microsoft adopted C++ for their object-oriented approach. Then Java came out, then C# came out. Okay, so in today's world, we could even say that the updated version of Java, the one that has the just-in-time compilers, is sitting right there, the same level as C#. And then over here, we just drop this down. We have the highly original Objective-C 2.0. Great naming. Great naming. Okay, so this is an updated version of the original Objective-C. Original Objective-C was basically a copy off C, and we're going to call that equivalent to C++. Then there was innovation over here, and eventually the innovation was brought into an updated version of Objective-C. Now, why do you suspect that there was not that much innovation in the middle here when we saw it growing over here? If we were to label these guys, we would say that this column is Mac, and we'd say that this column is PC, right? Why did we see such a long time period between this and this on the Mac side when we saw relatively constant growth? I know I haven't given you actually numbers of years here, but relatively speaking. We saw relatively constant growth over here under PC. Why do you think there wasn't so much innovation over here? Go ahead.
Hardware didn't change much for the Mac.
Well, I would say Apple computers keep getting faster and faster, just like PCs. Yeah.
I was going to say the same.
Oh, same thing? Okay, you're wrong. Go ahead.
Because Windows has, since it's made for a broader spectrum of computers, they can have multiple companies working on different programming languages for it, as opposed to Apple, since Apple only has Apple hardware and Apple software only runs on Apple hardware, they only have Apple able to work on the languages.
Okay, I think there's truth to that. To spin that a little bit, in terms of the number of developers in the world who are writing software for PC versus writing software for Mac, how many more people do you think were writing software for PC than for Mac? Rounding down, a lot, right? Okay, there was a lot more developers over here than over here. Go ahead.
Isn't the Mac side benefiting from the Java innovations too? Because it's of the nature of Java.
They are. They are benefiting from that as well. So they did get this idea over here, but most Java developers were still writing for PC. So they were PC developers who wrote in Java, hoping to get a couple of dollars over here. Why do you think it took so long? Because really, if we say the Objective-C to Objective-C 2.0, that's a similar jump from C++ to C#. That's that jump. We had a percentage of Mac developers over here, and they didn't really think there was a problem. If you think that, oh, go ahead.
Well, I just came up with the idea that Windows was getting hacked more than Mac was, and they didn't see any problems in regards to security. And
Okay.
I don't think they needed to change anything at all.
How many of you have heard that argument? That, oh, Macs don't get viruses, PCs do. Lots of times, right? Mostly from Mac fanboys, fangirls, be politically all-encompassing. Is that true? Is it true that Macs don't get viruses? PCs do? Sure it is. You Mac users, how many of you have had a virus on your PC or on your Mac? None of you. PC users, we all have to have antivirus installed, right? Why is that? Who writes viruses? Bad guys. Okay? And what do bad guys want to accomplish? Pissing off people. Right? So if you're a bad guy who wants to piss off people, do you want to piss off the 97% of the people or the 3% of the people? I mean, ideally you want to get them off. Right? But will you probably target the monster over here as opposed to the tiny, tiny percentage over here? Okay, it's not that Mac is virus proof. You can make an argument the modern day Mac operating system, because it's based on Unix, probably is higher security than the Windows operating system. But we're not talking about night and day. You might be able to argue that it's 5 or 10% more secure. Maybe. Okay? You know, we're not talking like Microsoft has crap and Apple's is great. Okay? These are both really solid operating systems. And like I said before, if you consider how stable Windows is and how good Windows is and the problem it's solving, it's pretty impressive. Okay? So, you know, but we all heard that before, right? It's actually related to what I'm going to say over here. So we've all dealt with, you know, Apple fanboys, right? We've dealt with that. We've seen it. Any of you, do you identify with that? Or are you passing out the Kool-Aid? Every time I go into the App Store, the Apple Store, I'm always wondering where their Kool-Aid is. It's got to be somewhere in there. There's a culture in the Mac community, isn't there? And if you go into the Apple Store, you feel that culture. It's different. You go into Best Buy and shop for a computer, it's a different experience than going into the Apple store and shopping for a computer. There is a culture, whatever it is. That culture is exaggerated 1,000 times behind the scenes on the developer side. From their perspective, Apple can do no wrong. So you had these guys for years and years and years working with these, let's call it antiquated languages, not complaining at all because we were real programmers. We're writing for the right platform. Over here, these are all pretenders. And they would convince themselves of this. Okay? There wasn't a need for anything better because this is the best already. Why improve on perfection? Was the mentality in there. Okay? Now, most of us are aware that Apple is a lot bigger of a presence in the technology world today than really they ever have been, right? Why is that? Is it because the Mac operating system has improved a lot? Is it because their languages are better? Why is it? iPhone. Apple hasn't made all these strides because their laptops have improved a lot or their desktops have improved a lot. It's the same crap, right? They have a big market share in mobile. Between iPhone and their tablets, the iPad, they have a huge market share. That's where their money comes from. Okay? That's where their focus is. There are more people programming in Objective-C today than there ever has been. And it's not because they finally jumped on the boat and jumped on the boat bandwagon, whatever. It's not because they jumped in that and decided, oh, we're going to start writing software for the Mac operating system. You had some of them. For those of you who are Mac users, are you aware that there is actually a Mac App Store? Where is that guy now? It's over here somewhere. There we go. Mac App Store. So you can download apps for your Mac. And as a developer, you can write stuff for the Mac. And it uses the same icon as the App Store for the iPhone and the iPad. If you had to predict which is the bigger App Store, which one has more apps on it, do you think it's the Mac App Store or do you think it's the iPhone, iPad App Store? By a lot. Okay? The people who are releasing apps on here are mostly the people who've been writing for Apple for years, writing software for the Mac for years, as well as folks who started their business writing software for the iPhone and for the iPad, and either had an idea for a desktop app, or their mobile app could be ported over to desktop, like Angry Birds or something like that, one of the games. Or maybe there's a benefit of having a complementary desktop version of their application that works in conjunction with the mobile version of their application. So most of the developers here are also developers on iPhone and probably started as developers on iPhone. Make sense? So this isn't their popular app store. It's just they're trying to make their stuff as seamless as possible. Everything gets installed from app stores, and that's just the way it works, blah, blah, blah. So for years and years and years, there was not a problem with these languages. But when they came out with iOS, and they came out with the operating system for the iPhone, and they came up with the idea for the App Store, they had to update their language with new core libraries to support the iPhone. So inside here, there's a library that Objective-C uses called Cocoa. That's their that's their stuff for making Mac applications. Well, they needed to make a updated version of Cocoa called Cocoa Touch that worked for touch-based interfaces instead of interfaces based on mice and keyboard. Make sense? So while they were updating that, why not just also update the language itself? Modern day Objective-C actually has some other advantages when they finally started working with various technologies. I could maybe make a reasonable argument that out of these three languages, Objective-C is the most technologically advanced now, but they were probably also the third the last one to show up. Java's been around for a while. C#'s been around for a while. Objective-C 2.0 has been around a substantially smaller amount of time. Okay, so when I go back to the slide of the big three is really talking about the three major languages that are being used in industry today. Okay, so we have three languages that have been around for a long time, but have been updated, refurbished more recently. Objective-C the most recently, C# second, Java third. All right, so what we'll do is when we come back next time, we're going to talk about how Java, C# and Objective-C are used in industry today. What role do they play? Because we want to use the right tool for the right job. Okay, these guys aren't all in competition with each other. There is some overlap, but generally speaking, you use Java for certain things, you use C# for certain things, you use Objective-C for other things. All right, I will see everybody on Wednesday.